keeping up with tech can feel like a chore, can't it? We get it. That's why we do these deep dives. Today, we're digging into something pretty cool from Google DeepMind, Gemma 3N for mobiles.
Yeah, this one's interesting. It's all about taking that really powerful AI, the kind that usually needs huge computers, and packing it into your smartphone.
Right, so Gemma 3N is basically a lightweight, efficient AI model built just for mobile devices.
Exactly. The core idea is to move beyond needing the cloud for everything, bringing advanced AI right onto the phone itself.
And that could mean, well, faster responses, better privacy because the processing happens locally, and maybe making this stuff more accessible, right?
Precisely. That's the potential aha moment for you
Yeah.
listening. We've been looking at an article, Gemma 3N para móviles, IA ligera y eficiente en tu bolsillo.
And our mission today is pretty straightforward. Pull out the key stuff about Gemma 3N and figure out what its impact might actually be.
Okay, so the big challenge Gemma 3N tackles is that, most powerful AI models need a ton of computing power.
Yeah.
Way more than a phone usually has.
Makes sense. So how does Gemma 3N get around that? What's the trick?
Well, think of it like this. It's a slimmed-down, optimized version of Google's bigger Gemma 3 model. Same brain, essentially, but engineered to be much more efficient. Lightweight.
Okay, lightweight, efficient, but what can it do? What are the actual capabilities?
The key is its strong natural language processing, understanding, and generating text. And it's specifically tuned to run well on, the limited hardware and battery of a phone.
Okay, so practical benefits. What does this mean for me using my phone day to day?
Faster processing, for one. Things happen instantly on the device. Also, enhanced privacy. Since data isn't always going to the cloud, it stays local.
That privacy point feels huge these days.
It really is. And accessibility, too, making advanced AI work on more phones, not just the top-end ones.
So what was Google DeepMind really trying to achieve here? What were their main goals?
Seems like a few things. Democratizing mobile AI, getting it to more people, optimizing performance specifically for mobile chips, Snapdragon Tensor, Apple Silicon.
Right, the chips inside our phones.
Yeah. And ensuring privacy through that local processing. Plus, making it easy for developers to actually use it in apps, using frameworks like TensorFlow Lite or MLKit.
Okay, let's get a bit technical, but keep it simple. What's actually under the hood that makes this possible on mobile?
Well, first, it's a lighter model based on Gemma 3, but with fewer parameters. The article mentions something like the 2 billion to 7 billion range, much smaller than the giants.
Okay, fewer parameters. What else?
It supports something called quantization, basically using simpler numbers like INT8 or FP16 for calculations, makes things run faster and use less power.
Ah, efficiency tricks.
Exactly. And crucially, it can work offline. Using those tools like TensorFlow Lite means apps can use the AI without an internet connection, though you can still connect to Google's cloud AI, Vertex AI, for really heavy tasks if needed.
Okay, bring it home for me. Give me some concrete examples. What apps or features might use this?
Imagine much smarter voice assistants on your phone, maybe even better than Google Assistant for certain quick tasks. Real-time translation that just works, even offline.
Oh, that offline translation would be amazing.
Right. Or think about chatbots inside customer service apps that are actually helpful and instant. Or even tools for summarizing text or drafting emails right there on your device. Productivity stuff.
How does this Gemma 3N stack up against other mobile AI models people might have heard of?
Good question. So Gemma 3N, in that 2B to 7B parameter range, is Google's Play, optimized for low power. Yeah, it might be a bit less capable than the full Gemma 3, naturally.
Okay. And others?
You've got models like Meta's Llama 3, maybe around 7B or 8B parameters, offers a good balance, but might need a bit more phone memory, more RAM. And then there's Microsoft's Phi 3, around 3.8B parameters. It's known for being really fast on mobile chips, but perhaps not quite as accurate for really complex stuff. It's all trade-offs,
Makes sense. Different tools for different jobs. What's next for Gemma 3N? What should we look out for?
We're expecting an official release in a format called .tflight, which developers love. Deeper integration into Android and iOS systems is likely. They'll want to improve the speed of real-time text generation, too.
And working with the hardware guys.
Definitely. Collaborations with Qualcomm, Samsung, Apple. Getting hardware acceleration specifically for this model, that would be a big boost.
Okay, so wrapping this up, what's the main takeaway here?
I'd say Gemma 3N is a really significant step for AI on your phone. It hits a sweet spot between being efficient enough to run locally and powerful enough to be useful.
That ability to run locally seems key. Speed, privacy.
Absolutely. It makes it ideal for a lot of applications. It might not be the absolute most powerful AI on the planet, but for optimized mobile AI, it looks like a leader right now.
And we can probably expect Google to keep improving it, right? More support, maybe better reasoning down the line.
Yeah, that seems like a safe bet.
So here's a final thought to leave you with. As this kind of powerful AI becomes common on our devices, not just in the cloud, how might that fundamentally change how we interact with our phones? Could we see totally new kinds of apps, things focused on instant access, and maybe, just maybe, prioritizing our privacy in ways we haven't seen before? Something to think about.